Hello and welcome to ChromSword. In this video, we're going to talk about ChromSword Offline modeling and how to use ChromSword Offline for computer-assisted method development. This will include data importing, optimization of conditions, including different types of models, and how the models can be adjusted manually. If you haven't seen the introduction video to ChromSword Offline, make sure to watch it before continuing in this video. The link for the video is in the description below. As mentioned and described in the first video, ChromSword Offline is a part of the ChromSword method development suite. That includes packages for automated HPLC method development with AI algorithms and automation of robustness studies. In this video, we will focus on the HPLC method development process with ChromSword Offline only, where the choice and screening of columns are done by the user on their instrument with any data system. ChromSword Offline has the ability to import data from different chromatography data systems, such as Chromeleon or OpenLab. But for this video, we'll be uploading data from ChromSwordAuto. This can be done by choosing the menu tab in the Compound section and clicking Import from CSRPTX and selecting the desired data file. For importing data from external chromatography data systems, click Import from external data systems and click on the desired data file. After the data which will be modeled is imported, in this window it is also possible to preview the peaks of the compounds in the sample. To preview the peaks of all imported runs, click on the drop-down menu on the right side of the window and click the desired runs. Also, it should be made sure that all of the peaks are named and tracked. For data generated by ChromSwordAuto, this can be done by using the rename and track function in the ChromSword report viewer. And as you can see here, we have different multi-segmented gradients, which allows ChromSword Offline to make data models. In the Runs section, it is possible to preview the information of the imported runs, which may be adjusted if necessary. The information which can be adjusted includes the runtime and gradient of the run, as well as the number of gradient steps, the retention time, width, and area for each individual peak. Once the peaks and runs information was validated, we may proceed to the Model section, where the system will build a separation model based on the information input in the previous steps, as well as the selected function. The models can be built based on varying solvent concentration, pH, and temperature. In this video, we are focusing on concentration models, so we are selecting concentration, and after we click Next, the system builds the model. Once the model is built, in the Design Space window, there are multiple options for portraying the data generated. Here we see a gradient linear model with 1D isocratic view. In the Design Space model window, we can see a graph comprised of generated data of minimal pair resolution versus solvent concentration. The x-axis shows isoprotic solvent concentration, while the y-axis displays the minimal resolution between critical peak pairs at certain isocratic runs, generated by the system. At the right side window, we can see a chromatogram for runs of certain isocratic solvent concentration. In the Menu tab, we can select LNK models. Now, the Design Space model window will display the behavior of calculated LNK values for each compound at different solvent concentrations. If we go back to pair resolution view, it is also possible to change the model type for data representation. In this case, we could select gradient for large molecules linear model type. We may also change the view to 2D start and concentration. Now, the Design Space model window displays a color-coded map, which shows the minimal resolution between critical peak pairs in generated solvent gradients. In the right side lower window, it is possible to change the upper and lower limits of the generated gradients, as well as the gradient breakpoint times and the duration of the chromatogram to be generated. The same window also allows for selection of peaks deemed critical, which informs the system to prioritize their separation. At any moment, whether it be during 1D, 2D, or LNK models view, you may want to save certain run conditions for later use. This can be accomplished by double-clicking any point in the design space model window, which freezes the chromatogram. In the chromatogram window, and the store method icon appears. Clicking this icon allows to save the method for later use. Once all the desired methods have been stored, we may proceed to the optimization window. In the optimization window, it is possible to instruct the system to build a model based on the input criteria. On the left side window, you may change the parameters for the models to be generated. This includes the length of the run, the gradient's concentration range, the preferred times of elution of the first and last peaks, the range of the gradient slope. It is also possible to change weight of certain peak pairs. What this means is that it is possible to instruct the system to prioritize the separation of certain peak pairs over others. The higher the weight, the higher the priority. Once all the necessary parameters have been input, click Optimize and wait for the software to generate the optimal gradients. The duration of optimization may be changed either by changing the optimization duration before the optimization has begun or by clicking Stop prematurely. The system will provide gradient profiles it deems to be optimal, with each containing an increasing number of gradient steps. Same as previously, each method generated may be stored for later use by clicking the Save icon. In the gradient section, each stored method can be tuned manually. This may be accomplished by adjusting gradient breakpoints in the table below the chromatogram on the left side, or by clicking on the breakpoints directly on the chromatogram and dragging them. Breakpoints can be added or removed either by adding or removing lines in the table below. Breakpoints can also be added by double-clicking directly on the chromatogram. An existing breakpoint can also be removed by double-clicking it on the chromatogram like so. To switch between stored methods, click Load Stored Method and select a different method from the provided list. All of the stored methods can be accessed and exported from the Stored Methods section. So, this is it for ChromSword Offline concentration modeling. Be sure to watch our future videos regarding pH and temperature modeling using ChromSword Offline in the future. Also, if you're interested in ChromSwordAuto automated HPLC method development suite, feel free to contact us at ChromSword.com.